In the second part of the lecture, we're going to look at the strain index. The strain index is a quantitative method that will let you evaluate for potential upper extremity MSDs, and it is a method looking at long-term exposure. It's described on pages 179 to 181 of your textbook. So the strain index is for the distal upper extremity MSD evaluation. Distal means further away from the body. If you've had an anatomy class, they probably talked about distal body segments and proximal body segments. Distal is further away, proximal is closer, and so looking at your arm, your lower arm to your hand to your fingers is the distal, the further away body segment. Disorders, as I mentioned in the TLV part of the lecture, disorders will include things such as tenosynovitis, which we know as trigger finger. Second disorder would be carpal tunnel syndrome, which is compression of the median nerve in the carpal tunnel. Radial tunnel syndrome is compression of the radial nerve in the radial tunnel, which is located about 2 centimeters away from your elbow bone, your lateral epicondyle. Disorders will also include lateral epicondylitis or medial epicondylitis. These you probably know more commonly as tennis elbow, golfer's elbow, bowler's elbow, pitcher's elbow, so any of those elbow tendon issues. Disorders will also include cubital tunnel syndrome, which I'd mentioned is the fastest growing upper extremity MSD. And this is fastest growing because it's tied to cell phone use. When people are holding their cell phone up to their ear, it's stretching and compressing their nerve for a longer term, and so that they might develop some ulnar nerve compression issues. The strain index itself is a 4-step process. So 4-step, the first one, observer, meaning you, will be collecting data on 6 factors. We're going to, from the data collection, we're going to turn those in step B, turn those into multipliers using some Rady criteria. Step C, we'll just multiply the multipliers together to find a product. The product is the strain index. And then on step D, we'll just interpret our calculation. And so on the first part, the 6 factors we're going to be looking at, these are combination of risk factors and characteristics of risk factors. The factors we're going to look at are intensity of one exertion, and so again I'm going to circle this one exertion only. If you were to do it one time, how intense is that effort? How forceful? How much effort is it? Second factor, duration of exertions. Duration of exertion. So out of a total time that you're being observed, what part of that, what percentage of that is the person actually moving their distal upper extremity? What percentage of the time are they grasping something? Are they applying a force? 3 is efforts per minute, and so that's simply your repetition factor. 4 is hand-wrist posture, and this will be looking at the hand-wrist. Are you in extension? Is your wrist in extension, flexion, or ulnar deviation? 5 is speed of work, and this will be a pacing factor. So pacing, are people self-paced, or are they machine-paced? Are they force-paced? And then lastly, duration of task. We're looking at the per day, as in how many hours per day are they exposed or on the task. Something else to note, you're looking at these 6 factors on the left lower arm or the right lower arm. So left or right, you're looking at the sides of your body separately. So you're not mixing and matching, you're looking at each one, and oftentimes we only look at the dominant hand to find the exposure level. Working through the same example that we used on the TLV, I've had to throw in some more information. You need more quantitative data. So there's still 4.5-hour shift. We're still sorting chips, but we need to know what is our repetition rate. So we're doing 50 chips per minute at a fast, safe, self-paced speed. I watched him for 15 minutes. So during this 15-minute observation period, his right hand was in motion, moving chips 75% of the time. And so out of the 15 minutes, he was actually moving using his right hand. I think it was like 11 1/4 minutes. So 75% of the time. His right wrist was in extreme extension, more extended more than 55 degrees while he was doing this task. And so I want you to use the strain index to evaluate upper extremity MSD risk. In your textbook, page 179 to page 180, so 179 to 180, it provides a table. It's cut it over 2 pages. Provides a table that walks you through this rating criteria. And so the risk factors that we looked at that I had listed, this will be risk factor 1, 2, 3, or I should say risk factor / characteristic. The first one's looking at the intensity of exertion, or the force, the effort. And so for this one, if you recall from the hand activity level TLV, the operator said it was a light exertion. He picked a value of 1 off the Borg CR10 scale. And so we can use the Borg scale to give you the information if we're evaluating intensity. The numbers in brackets are the Borg scale, and so he picked a 1. And so we circle a 1 for the rating. And then we want to determine, are we looking at the left hand or the right hand? And the information in my problem indicates that he was using his right hand, and so we're looking at the right hand only. And so I want to insert that score into my right hand column. For this problem, I'm going to totally ignore the left hand. He's not using it very much. He's using it much less. He's not using it at all. And so I'm looking at the right hand only. For the second characteristic, the duration of exertion, I said he was working, he was actually moving using his hand 11.25 minutes out of my 15-minute observation. That would be, if I divided those, that would be 75%. And I actually gave you that in the problem. So the duration of exertion is 75%, falls into 50 to 79. And so that gives me a value of 2. It's again right hand. Efforts per minute, the problem stated that was 50 reps per minute. That is greater than 20, and so for this one we have a value of 3 for the right hand. On page 180, the table continues, or actually I've cut and pasted so that the table appears somewhat differently, but the fourth factor we consider is hand wrist posture. In this case, I gave you the information 55 degrees extension, which is near extreme, and so we have a value for the right hand of 3.0 for that. For the speed of work, he was self-paced, and so I'm saying this is normal speed of motion. For this one, you're going to need to be careful. When you observe somebody doing the job that they've done for a long time, they might appear rushed, they might appear like they're working very fast, that you couldn't keep up with them if you tried the job. But you have to consider, is it normal for them or is it rushed for them? Okay, if they've been on the job, they can do it faster, and so most people will operate at a normal speed unless for some reason they're externally paced, such as they're working on a conveyor or assembly line. Things come to them, they don't have control over their pacing. In that case, they might be rushed barely able to keep up. But if it's self-paced, most people will either work at a normal speed of motion, as this one is, or they might even be working on the slow end. And then the last characteristic of the risk factor exposure is that he was exposed, or he was on the task for 4.5 hours per day. That's between 4 to 8, and so we give a value of 1. It's a normal shift. Okay, so we've evaluated all the risk factors. We've taken care of that first step. Second step, we've determined the multiplier values using the rating criteria. Okay, so we've done that. The last 2 steps are to calculate the product and then interpret. And so our calculate the product, we're going to go back and identify the ratings we just did from the table. We had a 1 circled, we had a 2 circled, 3. Next slide was 3 by 1 by 1. Okay. So we're simply multiplying those. We'll come up with a value of 18. So the strain index is equal to 18. Interpreting that high is bad, low is good. And so we're at a SI, 18 is greater than 7, so we are at a hazardous risk level. We expect that the employee in the task, on the task, is at risk, at significant risk for developing an MSD. The cutoff for this is there have been studies that have shown that it at a level of SI greater than 5, so strain index higher than 5, it was associated with MSDs. And so below a level of 5, it's the higher up to 5 that's uncertain. There might be risk, but starting at 5, they definitely did see MSD association. For our recommendation, now that we know it's hazardous, we want to control the highest multipliers. And so we go back, simply look at our multipliers. We see that we've got a 1, 2, 3, 3. So our 2s and 3s are our highest. Our last 3 is posture. We had extreme deviation, so we know we want to control posture. And this might be raising or lowering the table, raising or lowering the employee, maybe angling the employee. Our other 3 is efforts per minute. And so this was our repetition factor. It was at 50 chips per minute. And so you could look at pacing. Could we slow it down? Or pacing, could we go to a mechanized, an automated chip sorter? So can we get a machine to do something that's highly repetitious? And then lastly, the 2 is duration of exertion. Again, he was over 11 minutes out of a 15-minute period, so he's working pretty consistently. And so on this, again, something like rest breaks or mechanized would take care of that. Okay. Finally, you might be asking, it's like, well, when we did the TLV, it showed it was not hazardous. We don't expect to see MSDs in people. Versus a strain index looking at the same job, it gives you a hazardous level. Why is there a difference between the two evaluations? For this particular task, I want you to recall that the TLV considered only 2 factors, hand activity level and force. It didn't consider posture, versus in this one we have extreme posture. And so considering that as an issue, the strain index did account for posture versus the TLV did not account for posture. And so the TLV left you with, you need to add your professional judgment to that if awkward postures are present. And so in some cases you're looking at some different factors. You might get some different evaluations.